Good afternoon, everyone. Our report for today is all about the flow of math knowledge to the different parts of Europe. So, when we say flow, we are talking or we are discussing the succession of mathematics in the Europe. Or simply ask, ano-ano nga ba ang mga umusbong na math knowledge han mga European? So let's start from European mathematics since the Middle Ages, beginning in the Middle Ages. Beginning is the Middle Ages. Mathematics emerged from the fallow period that have begun with the fall of the Roman Empire. Such mathematicians as Leonardo of Pisa and Nicolas Oresme were able to apply and extend the knowledge that have been preserved in the Islamic world. After this time, mathematics progress continued in many Islamic countries. Mathematics also flourished in countries like Iran, Syria, and India through this work did not match the progress made by Greeks. But in addition to the Islamic progress, it did preserve Greek mathematician. So moving on, let's discuss some important mathematics breakthrough in European history during the Middle Ages of Renaissance. So European mathematics history during the Middle Ages and Renaissance until 11th century. So, a small part of the great mathematical corpus was known in the West. Also, almost no one could read Greek. Available came from the poor texts written in Latin in the Roman Empire with very few Latin translation or Greek works. And it treatises by Boethius about century 500 made Latin reduction of a number of Greek scientific and logical writings. And another one is arithmetic based on Nicomacheus was the means by which medieval scholars learned of Pythagorean number theory. So Boethius and Cassiodorus provided the material of the part of monastic education called the quadrivium. So, quadrivium is include the arithmetic, geometry, astronomy, and music theory. Trivium and grammar, logic, and rhetoric. So those three are the subjects. This formed the seven liberal arts which were taught in the monasteries, cathedral schools, and from the 12th century on, universities, and which constitute the principal university instruction until modern times. So let's move on to until 12th century. So let's talk about the geometry. So geometry was largely concerned with approximate formulas from measuring areas and volumes in traditional Roman's surveyor. About Common Era 1000, a type of abacus in which numbers were represented by stones bearing Arabic numerals was introduced by Gerbert of Aurillac, a French scholar that later Pope Sylvester II. So let's Let's proceed the transmission of the Greek and Arabic learning in 11th century. New phase of mathematics begins with the translation from Arabic. Important mathematical achievements of the Greek ancients and Islamic civilizations become available in the West. So Euclid's Elements, the work of Archimedes and Al-Khwarizmi's treatises and arithmetic and numerals and applied them in calculation. So let's proceed to algorithm. Algorithmus. So what is algorithmus? Algorithmus is a Latin from the name of Khwarizmi. Western texts and also introduced the Hindu-Arabic numerals and applied them in calculations. And modern numerals first came into use in universities and then became common among merchants and other laymen. And to 12th century, mathematics was studied from a theoretical standpoint in the universities. The universities of Paris and Oxford, founded relatively early 1200, were centers from mathematics and philosophy. And the particular importance in these universities were the Arabic-based version of Euclid, of which were at least 4. So such reductions of the elements were made to help students not only to understand Euclid's textbooks but also to handle other particularly philosophical questions suggested by passages in Aristotle. The ratio theory of the elements provided a means of expressing the various relations of the quantities associated with moving bodies, relations that now would be expressed by formulas. And also, in Euclid, we were to be found methods of analyzing infinity and continuity paradoxically because Euclid always avoided infinity. So let's move on to 13th century. So reckoning. So what is reckoning? Reckoning is the action of process of calculating or something estimating. So with Hindu-Arabic, numericals was used by merchants at least from the time of Leonardo of Pisa. First in Italy and then in the trading cities of southern Germany and France were maestri di abaco or rechemister through arithmetic in the various vernaculars. So in 14th century, Thomas Bradwardine or Wardini, who was active in Merton College, Oxford, was one of the first medieval scholars to ask whether the continuum can be divided infinitely or whether there are smallest part indivisibles. He compared different geometric shapes in terms of the multitude of points. He suggested an exponential law. So let's proceed to 15th century to 16th century Renaissance period. 15th and 16th century group of Tuscan artists including Filippo Brunelleschi, Leon Battista Alberti, and Leonardo da Vinci incorporated linear perspective into their practice and teaching about a century before the subject was formally treated by mathematician Italian maestra di Abaco tried albeit unsuccessfully to solve non-trivial cubic equations. So, is Scipione del Ferro found the first general solution of non-trivial cubic equations at the beginning of 16th century and rediscovered by Niccolo Tartaglia several years later. And Gerolamo Cardano or Gerolamo Cardano published the solution in his Ars Magna. So, Ars Magna or the Rules of Algebra in 1545, together with Ludovico Ferrari's solution of the quadratic equation. By 1380, an algebraic symbolism had been developed in Italy in which letters were used for unknown, for its square and for constant. By 1450, the symbols used today for the unknown, for example, x, the square root sign and the sign positive and negative came into general use in southern Germany. And by 1486, they were used by Regiomontanus and by Federicus Gerhard and received an impetus at the University of Leipzig from Johann Wiedemann. And Francois Viete applied the idea of distinguishing between known and unknown quantities in algebra with vowels for unknown and constants for known quantities, found some relations between the coefficient of an equation and its root. And the continuation of my topic will be discussed by Mr. Berlan Lanante.
Good day everyone. Today I'm going to report about the 17th and 18th century, the period of the scientific revolution, one of intense activity and innovation in mathematics, advances in numerical calculation, development of symbolic algebra and analytic geometry, and the most important mathematical development of 17th century. Invention of differential integral calculus that resulted in a major expansion of the subject areas of mathematics. By the end of the 17th century, a program of research based in analysis have replaced classical Greek geometry at the center of advanced mathematics. In the next century, by the 18th century, this program would continue to develop in close association with physics, more particularly mechanics of the theoretical astronomy. The extensive use of analytic methods, the incorporation of applied subject, and the adoption of a pragmatic attitude to question of logical rigor distinguished the new mathematics from the traditional geometry. The 19th century. Mathematics grew so much during this period that any account must regularly be selected. The growth of mathematics as a profession, mathematics are no longer able to rely on its scientific imports on the validity, develop mark higher the standards of rigor. Many outstanding questions in mathematics applied to the more conceptual approaches that come into vogue. Project geometry, making the calculus rigorous, Fourier of series, elliptic function, the theory of numbers, the theory of equation, non-Euclidean geometry, differential equation, linear algebra, the foundation of geometry, the foundation of mathematics. And the last is the 20th and the 21st century. The emergence of number of the theories whose power and utility reside in large part in their generality. George Cantor, pioneering work on the concept of sets, discover also the unexpected properties of sets. Poincare showed renewed interest at contemporary works in physics. Some subject made a major breakthrough in the field of mathematics, algebraic topology, development in pure mathematics, mathematical and physics and theory of whisper, probabilistic mathematics. That's all and thank you.